We'll be speaking with you all today about the chronic hyperandrogenemia in a female rat model and how the heightened levels of androgens impact the renin-angiotensin system in the kidneys of these rats. And so, polycystic ovarian syndrome is the most common endocrine disorder in reproductive age women. It presents commonly with androgen excess, ovulatory dysfunction, and, of course, polycystic appearance of the ovaries. There is also a cardiometabolic syndrome apparent in PCOS, consisting of insulin resistance, obesity, and, important for this study, increased blood pressure. Androgen excess is thought to be an important component underlying the cardiometabolic syndrome. However, it is currently unknown how androgens result in the increase in blood pressure seen in PCOS. The RAS is a major controller of blood pressure, and it's known to be regulated by androgens. And so dysregulation of this system, therefore, may be a means by which the increase in blood pressure occurs. So to examine this hypothesis, Western blotting has been carried out on hyperandrogenic female rats, and as well as a control, for major components of both the classical and non-classical pathways of the RAS. And so the gallery includes the stain-free blot images that were used in order to normalize to total protein content, so those can be viewed. And so if we look here in the cortex, we see that there's an increase in angiotensinogen in the half rats. And so that may point to an increase in blood pressure that we do see. And so there's also an increase in ACE2 and AT2R. And so these are both mechanisms that result in a decrease in blood pressure. This may be a mechanism by which these rats are able to counteract some of that increased blood pressure as a counterbalance mechanism. If we look in the medulla here, there's a similar story. We see that the feedback here with the ACE2 and the AT2R is increased again in the half rats. And so this may be a way that these rats are attempting to compensate for the increase in blood pressure. If we look in the plasma, we see that there's an increased plasma angiotensinogen level in the half rats, again pointing towards the increased blood pressure, whereas we actually see a decreased ACE2 activity in the half rats. And so this may also be a reason why we see the increased ACE2 expression in both the medulla and the cortex of the kidneys. And so in summary, we have noted a dysregulation in the RAS of the half rats. We propose that a renin inhibitor may be a valuable avenue of therapy. And so since renin is the rate-limiting step of the RAS, and we do see the increased angiotensinogen, this may be a valuable avenue of research. Additionally, augmenting the ACE2 response may be a valuable option, as we do see the increased expression of ACE2, and so an ACE2 agonist may help to ameliorate some of the increase in blood pressure that we see in this model. And so that is all. So I will be here for any questions. Thank you.